Moving along with our thread pool system, we're now going to take a look at the monitor thread. Lee, take it away.
All right, our monitor thread relies on our run method, so all the code that we're going to be working on is going to revolve around this method. I'm going to go ahead and collapse everything else. So all we have visible is our run method. Now, our run method is our manager. This thing is going to do pretty much the bulk of all the work. To accomplish this, we're going to use a while loop. For the moment, I'm going to say while true. This means that the moment this thread starts running, or fires off the start here, we're going to put the run method in an infinite loop. We're going to modify that in a bit, but I don't want to do it quite yet. So for the moment, we're going to throw it into an infinite loop. Now, in a previous video, we said that it's never a good idea to run anything that's in a thread all out. You want to put at least a bit of delay in it, so you free up some processor time for other functions or other methods and other programs and other threads to do their thing. Play nice in the sandbox.
Mm-hmm.
So we'll put our thread sleep for 10 milliseconds in there. That should be enough for what we need to do. Now, I'm going to do this kind of in a kind of a haphazard way, but it will make sense when it all comes together. I'm going to be putting in some debug information. Basically, I'm going to put in some console write lines that are going to be displaying what our system is doing. And then I'm going to comment in where we're going to put some code. And then I'm going to go back and forth between the two, and we'll implement a little bit more features as things go through. And, this video gets a little bit long. We'll split it up into multiple videos. We'll see how it goes.
Okay.
So the first thing, let's do a console.writeLine. Write line, come on. Seriously? Come on. You can do it. Alrighty.
It'll just have to be done manually.
Yes. Alright. First one is going to be waiting for more work. So these are going to delineate different parts of functionality inside of this method. Then we need to do a check. Well, we'll have to do some functionality. We're going to start off with waiting. Man, you did that on purpose, didn't you?
I didn't do anything.
All right, so I'll fix my spelling error. And then what we need to do, first bit of real functionality, is we need to see if there are any threads available. If there isn't, we need to wait until some threads are available. So we're going to wait for available threads. So we're just going to look and make sure and just sit here and spin, or we're really not spinning, we're just on hold until we get the notification that there's available threads so we can do more work. Mm-hmm. Once we get available threads, then we can fall through the next part of the method, which is going to clean up any threads that have finished. So we'll go ahead and clean up after completed worker threads. So always nice to clean up after yourself. Mm-hmm. After that, we're going to check our queue count. If our queue count is greater than 0, then we know that there's still work to be done. So let's do another console.writeLine. This one will be threads, whoops, threads now available with jobs in the queue. Basically a message that's going to tell us how many threads are available to be allocated or are available for work and how many jobs still remain in the queue. So we'll get how many jobs are available from get available threads and our queue.count will tell us how many jobs we still have in the queue to be processed. After that, we're going to need to allocate worker threads to available threads. I can spell really. I think I still spelled that wrong, but is that right?
I think so.
Cool.
Available? No, it's available, but that's okay.
Yeah, see,
It's a
I thought
comment anyway, so.
I thought it looked wrong. I wasn't
Yeah.
quite sure. It's like, it's early. All right, so if we have any available threads, we're going to allocate worker threads to those available threads. And of course, that means we need to start them as well.
Yeah.
After that, a couple more of status updates. So we're going to check the queue count. If queue count is greater than 0, or worker threads.count is greater than 0. Then we can say our state equals to thread pool there we go, thread pool state dot processing. So anytime there's jobs in the queue or we've got worker threads, we know we're still processing. Else, our state is going to be idle.
Okay.
Put a semicolon there. Clean that up. If we get to be outside of this while loop for any reason, then we know that our state is stopping. All right, so that will handle the logic flow of it. None of the code is implemented yet, but it is going to show where we're going with it. Now, I want to deal with this true. I put this in just temporarily so we wouldn't get an error. Now, with the way this loop is going to be handled, we're going to continue to loop until a unique condition exists. That condition is going to be when we are exiting the program. So whenever we are no longer, or we're getting ready to exit, then we can kick out of this. So to do that, we're going to need another field or a new property. This is going to be is quitting. And it can't resolve it, obviously. So we're going to create this as a property. Well, you really had to put it there. All right. So we'll go move it up. Aw, man. Fail. All right. Well, ReSharper doesn't want to play. I'll do it manually. So we'll go up here. Public. Static bool. And let's see, do I want to put it as is quitting, or do I want to change the name? I'll put it for is quitting for now. Keep it consistent.
Sure.
Get set. Otherwise, I'll bite myself later. All right, this is something that I do want to be able to be set externally. This is how we're going to flag that we need to quit.
Mm-hmm.
So then, well, all of this opened back up. Okay, well, not is quitting then instead of true. So basically, if we're not quitting, we're going to continue to loop this. The moment is quitting gets set to true, this is going to fall out and our state's going to be set to stopping, and we're no longer going to process our thread pool.
Okay.
And let me go ahead and do a little bit of cleanup work. I'm also thinking, because I'm not happy with that. See, this is the cool thing about being a coder, and this being your own code. You can do, you can make it anything you want it to be. All right, this is what I'm going to do. I was just not happy with that, so I'm changing it. Coder's prerogative. I'm going to make this a private static bool. And I'm going to call it quit. Or, let's see. Actually, I don't even want to call it. Yeah, I am going to have to call it quit. Okay, so this will be quit. And then from quit, all right. Public get set. I don't like the is quitting part.
Okay.
The is quitting is based off of how I had set it up inside of Unity. And I realized that the way I had set it would mean that you've got to make your Unity project a very specific way. And I don't like that idea because I want this to be more flexible. I also don't want to force somebody to have to use this library only inside of Unity in the way that we specifically set up our Unity projects. So by setting this as quit, now you can set this on your own, which will quit the manager all on its own, without having to rely on what I had before, which was game manager is quitting. Because in some of our Unity projects, we use our own game manager. It's a very specific class called game manager, and inside of game manager, we use that to call all of our updates, and on application quit, which set a flag that is called is quitting, which is a public static on the game manager. If I kept that mechanism in this code, then that would mean you would have to have a class called game manager. That game manager would have to implement a flag called is quitting, and it would have to be set on application quit. That is forcing a very specific method of implementation and operation on the end user of this set of classes, and I don't want to do that. That's why I was recoding this.
Okay.
So, sorry, little sidetrack, but I figured it just ends up with more flexibility in the end.
Sure.
All right. Now, that's what I want to cover in this first part. This just gets our logic flow going, sets up the initial run method with what's going on, how we set the states, we need to come back in the next video and we're going to start implementing the functionality for each of these 3 sections of code.
Okay, sounds really good. That's going to wrap things up for this video. Thanks a lot for watching.